Hi everyone, I'm Christina and welcome to video 6 in our A-level trigonometry series. In this video we're going to look at the graphs of trigonometric functions and highlight their key features. So some of the objectives of this video are to look at the graphs of sin x, cos x and tan x for values of x between 2 pi and minus 2 pi, identify key features of each graph such as the symmetry, maximum and minimum points and the period of each graph, and acknowledge that all three graphs are periodic. So what this means is that they repeat themselves. So we're first going to look at y equals sine of x. Let's start by observing the maximum and minimum values of the sine graph. So the maximum value of our sine graph is positive 1, and the minimum value is negative 1. So we can say that the range of our sine graph is between 1 and negative 1. So we can write that as negative 1 is less than or equal to y is less than or equal to 1. At the moment, we're only looking at the graph between minus 2 pi and 2 pi. So we've restricted the domain to that interval. But of course, our sine graph is periodic, so it repeats itself every 2 pi radians. So it's going to look exactly the same from 0 to 2 pi as it would from 2 pi to 4 pi and so on. So we can make a note that the domain, we've restricted the domain in this case between 2 pi and negative 2 pi. So summarizing some of these key features, we can see that the maximum and minimum values occur at regular intervals along the graph. So we can see the maximum values up here and the minimum values down here of our sine graph. We're not going to state the values of x for which these maximum and minimum values occur just yet, but we're just highlighting that they do occur at regular intervals along the graph. The period is 2 pi radians. So what that means is the sine graph repeats itself every 2 pi radians. It also has rotational symmetry about the origin. So visually, this means that if you rotate the graph by 180 degrees about the origin point here, it looks exactly the same. This property belongs to odd functions, and this is something we were introduced to in video 2 of our trigonometry series, and that is that sine is in fact an odd function, which means that sine of minus x is equal to minus sine of x. So next, let's have a look at y equals cos of x. So just like sine, cosine has a maximum value of 1 and a minimum value of minus 1. So the range is exactly the same. We can make a note of that. So the range for our cosine graph is also values of y between 1 and minus 1. Now, a key difference here, which again we'll look at further in a later video, is that for the value of 0 on the x-axis, the sine graph gives us a value of 0 for the y. But for cosine, when we look at our x value of 0 radians, it gives us a maximum point up here. So this is a very key difference between the sine and cosine graphs. However, cosine, just like sine, does repeat itself every 2 pi radians. So we can see here between 0 and 2 pi, that's one cycle of the cosine graph. So it has a period of 2 pi. And I've summarized that here. It's worth making a note that we are, in fact, looking at the restricted domain here. So it's for values of x between 2 pi and minus 2 pi, similar to sine. It's the exact same thing. But the key features that I've summarized here are, again, maximum and minimum values occur at regular intervals along the graph. The period is 2 pi radians. I'll just explicitly write here. This means that the cosine graph repeats itself every 2 pi radians, same as sine. And cosine is actually symmetrical about the y-axis. So if we have a look here, if we look at the y-axis, we can see that the graph is a mirror image of itself across that y-axis. And this is a property of even functions. So cosine is an even function. And it means that cos of minus x is equal to minus cos of x. So now let's move on to y equals tan x. So this one looks very different, and it has these dashed vertical lines here. We call these asymptotes. So I'm actually going to label that on our tan graph. So I've highlighted these in purple. So these are asymptotes. What this means is that at certain values of x for our tan graph, we do not have a defined value of tan x. So if we have a look here, I've highlighted the key features that the tan graph has is that it has these vertical asymptotes, and this is where tan x is undefined. So these occur at x, values of x equal to pi over 2 plus n pi for values of n where they are all integers. So because the graph of tan x has vertical asymptotes and increases without limit between them, it has no maximum or minimum points. Oh, let me rewrite that as maximum or minimum values. And its range is all real numbers. So the tangent graph has rotational symmetry about the origin, similar to sine. So in fact, it is an odd function, just like sine. And so we can say that tan of minus x is equal to minus tan of x. And instead of having a period of 2 pi, tan actually repeats itself every pi radians. So we can kind of see here, I'll highlight it from 0 to pi. Our graph looks exactly the same as it does between pi to 2 pi and so on. Okay, so to summarize, we've looked at the key features of the sine, cosine, and tangent graphs, including their ranges, symmetry, periods, and even asymptotes for the tan graph.